And this is a proud definition with a long history. It was established in 1920 at the American Institute of Electrical Engineers meeting. And Michel and I think they made a mistake. And we have propagated that mistake for 100 years.
When engineers measure electrical power, they have to calculate the part that's going to be wasted. And it turns out that the standard method is only correct under the most ideal of conditions. The rest of the time is not using all the information that it needs to get the right answer. Prof. Gaunt and Prof. Malingray have been studying non-ideal conditions. One example is the heavily loaded townships where there's some illegal connections and the currents are quite unbalanced and distorted. Another example is during solar flares, there are distorted conditions that can actually take down the power system and certainly damage all of its components. Our calculations are wrong because we don't use the right information. At University of Cape Town, they've invented a device that can extract that information and then provide optimal compensation in the network. That's why my colleague Dr. Darwish and I also have been helping with the vetting and study and kind of further design of this device that they've invented. We want to learn from them and help them understand what could the implications be once their patented device starts to hit power systems around the world. So we had to perform some measurements, and we also went back to the drawing board and thought about what this could mean for the design of the power electronics involved. Dr. David Oyedokun is one of my counterparts at the University of Cape Town. We spotted a number of ways to collaborate in the future.
At the moment, we are planning to develop an axis of African and British research groups that will study the integration of renewable energies, particularly into grids.
Come in. Ah, you found it. Nice. Professor Comley Foley and I had extended conversations about how his team is going to tackle redoing power system stability for the case of solar flares and take into account the University of Cape Town power theory. Upon my return to London, we had to get together and plan out how would we do this workshop.
It's the same argument that in Manuel's way people really battle with.
In particular, we need to think about how we would expose the participants to this new idea and also take in their feedback. Along the way, we discovered how to deliver a new tool, which we now made freely available for people to explore the theory themselves.
Universities really have big responsibility. And whenever I go to our friends in universities, I say, look, just go back to the basic, review electrical engineering books. The method that was produced back in 1800s, 1880 something, may not apply now. Revisit that, see what you get. See what better definition you come up with, where it applies, can be applied from DC right to any frequency.
The workshop has emboldened us to move forward with continuing to challenge these definitions in a wider way with a lot of discussions. Dr. Darwish and I have also started new lines of inquiry in our laboratory. The theoretical collaboration, the experimental collaboration, is something we expect to continue with the University of Cape Town for a long time. And that's why both institutions would really like to thank the Royal Academy of Engineering for supporting this kind of interaction.